Okay, I want to talk to you about Newton's first law right now. It's commonly stated as an object at rest will stay at rest, an object in motion will stay in motion. I've given you a slightly different definition on the board here, which is just to say objects maintain a constant speed and direction of motion forever and ever unless an unbalanced force acts on them. Meaning, according to Newton's first law, an object that's moving will stay moving in the same direction and stay moving at the same speed forever and ever unless there's an unbalanced force acting on it. If you push a car or if you push a block across the floor and the block comes to a stop, the fact that it comes to a stop tells you that there must be an unbalanced force acting on it. Because if there was no unbalanced force acting on it, it would keep going forever and ever and ever. In the case of the block that you push, that unbalanced force is friction, right? So friction creates an unbalanced force. Newton's first law is pretty simple but pretty profound and changed really the way that people thought about things. It used to be that people thought that objects at rest naturally came to rest, but Newton showed that they do not. So imagine this. If you throw an object in space and there's no gravity around or anything in it, that object will keep going in the same direction forever and ever and ever. Now, if a car is driving and there's no unbalanced force on it, no unbalance means that it must be balanced, right? So balance equals constant speed. So any object on Earth that's moving at a constant speed should have balance and therefore keep going at the same speed in the same direction forever and ever and ever. If it doesn't, then there's an unbalanced force acting on it. Imagine this, circular motion, for example, an object going in a circle. It could be moving at a constant speed, but if it is moving at a constant speed, it still does not have a constant velocity. It still must have an acceleration because its direction of motion is changing. In the case of this, it would have a net force and thus an acceleration towards the center of the circle, and its speed might be going in that direction. But when it goes halfway around, or quarter way around the circle, its velocity is now going down, and its force and its acceleration are towards the center of the circle. So anytime either the speed or the direction of motion changes, you've got to have an acceleration and a net force acting on an object. Now, Newton's first law is sometimes called the law of inertia. And so if you ever see this term inertia, I want you to just cross it out and write the word mass. So, for example, what has more inertia? A 2 kilogram object that's moving at 10 meters a second, or a 5 kilogram object that's moving at 1 meter a second. First one's going a lot faster. Fewer number of kilograms. The second one's going a lot slower, but more kilograms. This sort of question becomes really easy if you just realize what object has more inertia is the same as what object has more mass. And you find out that the speed or the velocity doesn't matter at all. What has more mass? The object with more kilograms, because kilograms refers to mass. The one last point I would like to make is when I say an unbalanced force acting on them, and we're going to see a little bit more on this very, very shortly, there's a word for unbalanced force. That would be a net force. So it's saying unless the unbalanced force acts on them, unless it has a net force. If your net force is 0, that tells you Newton's first law is kicking into effect. Constant speed, constant direction of motion. forever and ever and ever until that net force changes. An object at rest is considered not moving, so it works for that too. An object will maintain a constant speed of 0 forever and ever, or will stay at rest as long as the forces are balanced. That's Newton's first law. Thank you very much for watching.